Ok, we are online. Boa noite, pessoal. Bem-vindos ao último dia de Serverless Week. Tá? Hoje, no quinto dia, a gente tem uma pessoa muito especial com a gente. A Jennifer, ela vai estar falando aqui sobre Ops em Serverless. Lembrando que depois da talk dela vai ter mais uma talk, que é a talk do Renato Groff, tá? Sobre Azure Functions também, tá? Então, fiquem por aí e tal, e podem postar suas dúvidas. Como essa talk vai ser inteira em inglês, alguns disclaimers, tá? Como essa talk vai ser inteira em inglês, a gente não vai ter a tradução simultânea, a gente vai tentar traduzir com legendas depois e colocar o vídeo normalmente. Vocês podem fazer as perguntas em português mesmo, que eu posso passar aqui, eu vou estar ouvindo, eu vou estar lendo todo o chat. Eu vou estar pegando as suas perguntas em português e posso estar traduzindo essas perguntas para a Jennifer em inglês também. Ela vai responder e eu vou traduzir e postar de volta para vocês. Ou então vocês podem fazer a pergunta em inglês normalmente, tudo bem? Beleza, so Jennifer, it's up to you now.
Great. Hi, I'm Jennifer Davis, and I want to share a different perspective on serverless. I come from an ops background, most recently in SRE at RealSelf prior to joining Microsoft as an advocate. At RealSelf, we were doing some really fun things with serverless on AWS using the Serverless Framework. And what this presentation comes from is that experience. So once upon a time, a long time ago, I started using computers. And one of my early joys were these text-based adventures. There was this one game called Transylvania that I spent hours trying to solve. There weren't instructions about what to do. The game starts out with the player dumped on this path with a stump and indecipherable text on it. Play happens by inputting commands at a prompt. So you could go north, south, east, west, or try to interact with objects that were in view. Of course, there were vampires and werewolves. And the goal, there was a few different goals, but you were trying to save someone. Now, I kept getting stuck at various points because so many of the things I tried weren't parameters that the game designer had implemented. And it was only this year that I discovered how challenging solving this game actually would be. It was nothing like I would imagine. You're supposed to sing some song to a wizard, and I would never have guessed that. So I think about that a lot with the software that we create. We're often approaching technology from this perspective of that game designer. And then our users are trying to figure out what was intended based on their interactions with it. Versions, implementation, configuration, all of the software adjacencies and dependencies all affect the complexity of the software. The software also reflects the organizations that build, use, and maintain it. It also reflects our customers' use. We don't always imagine how customers use the software and get benefit from it. It's not like I'm implying that there should never be any complexity. There should totally be complexity. Our environments are complex, but there's important work towards distilling the accidental complexity that comes from building our systems, so they're left with only that which is essential to the software itself. Operations work is key to distilling that essential complexity. I find it so challenging and interesting. So much of it is about being these puzzle builders with all these different multiple puzzles that have just been dumped out in front of us, and we're trying to build these different puzzles out such that we're creating and sustaining value for our organization. Whether it's software that's built in-house or open source software or third-party services, the type of work that we do ranges. I just came up with some of these different roles and responsibilities that we have, and this isn't everything. Now, it's not that everybody that's in operation does all of this, but it's definitely within our wheelhouse. Often I think people think about operations as in just operating infrastructure. Another challenge is that often the work that we do is pushed towards the reactive operations work, where the focus is identifying the health of the system now and how to fix anything that is broken, because that's what's impacting customers and impacting the value that we're bringing right now. When so much of the work that needs to happen is the operations engineering work, and that's focusing on the proactive nature of operations, where we apply scientific method to design, create, and analyze available solutions with an awareness of the value to our companies, as well as thinking about government compliance, the risk to our organization, and safety concerns to humans. This is one of the joys I have with digging into how things work. Often I'm looking at what folks say a particular piece of software does, what it's supposed to do according to the documentation, and then what it does in practice, primarily in the ways that the customers are using it. Often these perspectives of software are entirely different, and these differences can affect how complex the software is to run and manage in production. This leads to impact to the customer's use of the platform. So let's look at serverless with this operations lens. The specific type of serverless I'm going to talk about today is FAS, which has a set of indicators that people associate it with it. That there's no servers to provision, that it scales automatically, that there are no idling costs, and increased availability. I'm not going to focus on the software differences or even talk really about platforms explicitly, because there isn't a one-to-one mapping of functionality, and different platforms have focused on different areas to solve problems. There are common use cases that benefit from serverless regardless of platform. Some of the reasons we might choose serverless is for web applications with high volume transactions, things that we want to isolate and have automatically scaled. Maybe data processing, especially for things that only run once a day or a month, and we don't need a server running 24/7. I somewhat see how Hadoop may no longer need to be something that people manage. Chatbots and IT automation are also great use cases. Often people don't think about having these admin servers that people have to run from an operations standpoint. Maybe we want something that on a schedule audits all of our servers to make sure that Chef is actually running in our environment. We don't want to have orphaned nodes that aren't getting the proper software and configuration. So two of these benefits I often think of as their perceived benefits, the simplified operational model and pay for use, when really I think there's the actual benefits that we see. And these actual benefits is about the additional choice we have about relinquishing precise control over assets that we don't want to manage, and that through that choice we can reduce our cost. I remember when we started moving servers into the cloud and leveraging APIs that were available to us to spin up infrastructure. I really, really valued not having to procure rack and stack, cable, install, and configure hardware. I ripped multiple pairs of pants in that process, and it's been such a benefit to my clothing budget. Now I have readily available systems that I don't have to do that kind of stuff for. There are very few folks that are really good at data center management and enjoy that kind of work. There are even fewer companies that this is an operational benefit to their organization, meaning it makes a difference in the value that they're bringing by running their own data centers. There was a change in our job skills in operations work, but it didn't change that we needed operations work done. Now, as we continue to move up the stack, we're going to continue to change what the work that we do looks like. It doesn't mean no ops. It just means we're changing it. So we're eliminating some of the toil of the work that we do, but we're also increasing our operational complexity as we go up the stack. I really liked this tweet that came out from Brian Friedman. We need all of these things in our environments. And so it's just adding additional complexity to our organization's footprint. So we really need to think about how we're managing them and the oversight. So much of what we talk about when we talk about serverless is focusing on just one aspect of the software lifecycle. In this diagram, I'm depicting where we're focusing a lot of our efforts in documentation and intro tutorials. We talk a lot about how to develop for serverless without thinking about the build, release, deploy, and monitoring. Going back to thinking about what it is that I had to manage when I had to manage physical hardware, there was all of these steps to think about with asset lifecycle of hardware. Well, if I think about it, serverless also is an asset. It's not a physical hardware asset, but it's an asset to my organization. So the steps are simplified, but I still need to consider them. As an organization, we still need to plan what we need out of our components. And we need to think about the mechanisms that we're using to deploy them. We also need to think about how to support them. It's not that the platform is going to identify what our customers need and get out of the value of our systems and automatically fix the problems for them. And then we also need to think about how we retire any functions gracefully. We can't just leave things running without some oversight. So let's go back to this life cycle and maybe spend a little time talking about some of the areas where it's helpful to think about what is needed with serverless. So we'll start out with discovery. One of the aspects that becomes more complex with serverless is that we have to think early on about the governance of the application, meaning we need to understand who has access and how we have access, and understanding how we audit that access. We don't want to create root-like access that puts the rest of our assets at risk, especially when serverless is so easy to scale up. We also need visibility into the functions that we have running into our organization. Without any oversight, we're not saving money if those functions are idling. They're not really idling, they're still getting hit on the endpoints, and they're just failing silently. We're creating situations where our customers might be experiencing something we don't even realize is happening because that one person who knew about the system is gone. We also need to understand how to plan for and budget our spend across our different services. While functions might scale seamlessly for their requirements, any other services in use might not have the same capabilities and might have limitations that we haven't factored in. For example, data stores are a really good example of infrastructure that has serious implications if they're hit by a large number of requests in a single frame of time. So if we're not planning for this because we have multiple different functions that are hitting the same data stores as well as other legacy systems, we might have impact that hasn't been thought about. And we have to get out of this reactive mindset of operations. We want to leverage the cloud capabilities and enable engineers to do the work they need to build value. We need to eliminate some of the mysterious impacts and think, oh, like this is just fine. Much like crufty code, tests, and alerts, serverless functionality needs to be maintained and cleaned up, especially when the functions are created from consoles rather than following well-defined practices that we use with our other software. We have to get out of this reactive mindset and accept that we have to have we don't need to have environments on fire because it's the way things have always been done. We need to think about our service resilience, and that includes thinking about having only one person knowing how the application functions. There's great utilities like the Serverless Framework that allow us to create a project template that implements the basic features that all projects should include and encapsulates specific security patterns that should be replicated across all projects. Those are a really great way to get people started to understanding what it is that we need to do. You can select a framework like the Serverless Framework that allows you to define your function in code alongside all of the infrastructure components required to get connected with specific resources. This is really great because in some ways I think of this as like a DevOps tool. We can get our dev, our ops, our tests, and our security folks all together working in the same project repo, working on the same code. So I talked a little bit about discovery. Let's go ahead and talk a little bit about monitoring our application. I think about service health with serverless as all of these different pieces of small environmental applications all across the organization that are just working and playing, and we want them all to work seamlessly. We don't want to end up having our customers reporting issues or having stuff fails and harming our environments. I think the challenge that we have is in some ways we've gotten used over time of thinking about how we see systems from the outside in. When we used to monitor things, we got so many free insights looking at the systems they were running on, whether they were the CPU, memory, the disk utilization. These metrics told us a story about our systems and gave us some information that we could then leverage to understand what was going on. So how do we actually do this when we don't have that information anymore? How do we monitor our serverless functions? I'm going to tell a little story about one of my experiences with serverless. Now, it was on AWS and it was using step functions, and it was pretty interesting because I really liked being able to see all of these different pieces connected. So in serverless, with the step functions, you can see all of the different functions, and you can see when something's running, it's green. And when it's not running, maybe it's yellow or white, and if it fails, it's red. We had this particular step function that would copy over the production database, filter out any personal identifying information, and then from that, take a sample of all of the data that we had so we could actually use it in testing and pre-production environments so we could make sure that our application was running correctly. Now, the only sort of metrics you get by default in AWS are duration, invocations, errors, and throttles. Now, I've talked to a lot of people, and I've discovered that some people don't even look at these metrics. And so at a starting point, it's really critical, whatever platform you are using, to leverage those metrics that are available to you. But the challenge is that sometimes these metrics aren't enough. And sometimes the application isn't giving you a really detailed view into what's going on. And so we have to take a step back and think, how are we going to figure out when something's going wrong? In this case, what we discovered over time as we were debugging it is we had logic errors in our application where we were trying to solve for problems where we had multiple instances running, and occasionally systems would overlap each other so that we would have multiple databases starting and they were attached to the same data store and corrupting the data. But we weren't actually getting any errors out of this other than that we didn't get the outcome we wanted. We didn't have a database to start from at the end. So it's absolutely critical to start with the metrics that you get from your platform, but then also understand you need instrumentation to dig into more what is happening on your environment. Create aggregate dashboards to visualize. So when you do have issues that come up for you, you have a way to see, one, the time frame that the problem started happening, and then two, to dig into what it is that is happening. Different platforms are going to have different functionality. So on Azure, we have Azure Monitor and Azure Application Insights, and there's a lot more different metrics that are available to you, as well as telemetry data. It's really important to use whatever software that you have to add that instrumentation as well. When I think about failure is going to happen. And with serverless, it can be even more painful because you might not realize that it's happening. You have to collaborate with your customers to understand what are the key indicators about the systems you're building and how to identify those failures. You don't want to create scenarios where you're creating bad experiences that will linger with your customers and impact how they view your site or service. I think a lot about what we're building and how we're building it and how we're automating things. It's really critical to think about the software that we're building and the opportunities we're creating. Just because it's easier and faster to deploy, to develop against, we want to make sure that we're not creating opportunities that have vastly bad experiences. When I think about going back to that game, that's a game, but we're creating such rich experiences that have much more impact to much more people. And it's so critical for us to think ahead of time about what that impact is. We have the opportunity now to shape how operable serverless is and what it is that we're doing so that we can have adequate information about how to successfully navigate building and maintaining applications that use serverless and how we work in the real world. I'm really excited about where we're going with serverless and what our options are. And we just need to talk more and share more about what people are doing so that we can shape this operability of serverless. Please join me in Slack conversations on Serverless Forum and the Serverless Ops channel. If you're blogging, please add operability information, visibility, and observability. Talk about what it is that you do when you find something wrong, not just about how you got started, but figuring out what things are happening. And if you have challenges, please do email me. As an advocate, I am excited about being able to help solve these problems for people. Thank you so much for your time, and I'd love to hear if you have questions.
Okay. Let me just see here if we have any questions. Okay, no questions. So let's finish this session, okay? So thank you a lot, Jennifer. Thank you for joining us here today on the Serverless Week, the first ever Serverless Week. We hope to see you on the next year, okay? So right now I'm going to just have the presentation finished, okay? Em português here. Então, galera, muito obrigado a todo mundo que ficou aqui e assistiu a talk da Jennifer. Tá? Nós vamos colocar as legendas agora no final da semana, na semana que vem, vocês já vão ter legendas aqui. Então, fica com a gente aqui mais um pouquinho, às 8h50 agora vai começar a próxima talk do Renato Groff, tá? Sobre Azure Functions e multiplataforma. Então, fiquem ligados aí, compartilhem com o pessoal, ajuda a gente a manter esse evento cada vez melhor, tá? Então, feedbacks, qualquer coisa, entra lá no nosso site, slsweek.netlify.com. Beleza? Falou, galera!